All right.
Hi.
Hi. Welcome to week 4 of Understanding Quantum Computers. What should we talk about today?
Okay, quantum-inspired classical algorithm.
Quantum-inspired algorithms. That's a good choice. What's a quantum-inspired classical algorithm?
Okay, it's algorithm for classical computer, but it's not found directly. The core point of algorithm is inspired from quantum high-speed algorithm. Okay.
So the most famous example of this is probably a person we could call, I guess, a quantum native, Yiwen Tang. So Yiwen Tang's a researcher. She's now a PhD student at the University of Washington. And her bachelor's thesis in 2018 at the University of Texas at Austin created quite a stir. Do you know what a recommender algorithm is?
I found that paper yesterday. That paper name is a quantum-inspired algorithm for recommendation systems. Actually, I've heard about that paper last year. You know about that paper?
Yeah, I heard about it last year, but to be honest, I hadn't sat down and studied it closely. So now's a good time to do it. Now's a good time to talk about it. First off, so what's a recommender algorithm? Do you know?
No, unfortunately I don't know about that topic well.
The recommender algorithms are like Amazon, when you go to Amazon and it recommends products for you to buy. Some of that work was actually originated by a friend of mine named Pati Mais, who's now a professor at the MIT Media Lab. Well, I guess she was even when that core work was done in the 1990s. She did some of that work. Well, now it's sort of a standard part of what any sort of e-commerce system does. You have maybe M users and N products, and you're trying to figure out how to recommend products to different people so that you increase the probability of them buying stuff and increase everybody's satisfaction. So that's what's called a recommender algorithm. A couple of researchers, one named Jordanis Karanidis. You know Jordanis?
Yeah.
He's a researcher at the Université Paris Diderot in Paris. And Jordanis and his collaborator, Anupam Prakash, proposed a quantum recommender algorithm in 2016. This quantum algorithm of theirs was believed to be exponentially faster than classical algorithms for certain kinds of recommendation queries. It was exponentially faster than the best known classical algorithm at the time. Right? So the expectation was that the quantum algorithm was faster than the classical one. But sometimes we're wrong about things like that, right? So Jordanis and Prakash's, or Karanidis and Prakash's algorithm in 2016 was this fastest known algorithm. It depended on a couple of things. Number one, it didn't really solve the full problem. It was kind of inspired by the HHL algorithm, Haro, Hasidim, and Lloyd, which is one of the first quantum machine learning algorithms. It really inspired an awful lot of work. Their algorithm's a little bit different, but like that, it involves some assumptions, one of which is the ability to quantum query a classical memory.
Okay.
So, do you know how that works?
Sorry, I cannot imagine about that.
Yeah. So the idea with a QRAM is one of the terms that people call it, a quantum RAM, is that you have a classical memory with some sort of key or an address and a set of values, but you can put in a query that's in superposition, and then you get back all the answers in superposition out of it. This is what I call the billion-dollar problem in quantum computers.
Okay.
If you find a way to build a device like this efficiently, somebody's going to pay you a lot of money for it. You're going to be rich and famous in some way, shape, or form. Well, the HHL algorithm assumes the existence of such a device, and so does the Karanidis and Prakash algorithm. So it's one of the underlying assumptions for what they're doing.